everybody, happy Monday. What I've done is in the handouts for Blackboard, I have the 4.1 posted, which I'm going to run through today. And then I have some problems I've written that is a worksheet also under handouts for Module 4 that I will run through on Wednesday. So on the final exam, there's a few questions that deal with lines, so it is important that we go over this. And we're going to hit the most important points, and so you should be fine on the final exam. So you don't need to copy this, okay? You can just take some notes on it. If you want to print it, awesome. But let's just get started with it. And then we're going to cover 4.1. I'm not going to post 4.2. That's what my worksheet's for, and that kind of covers the rest of it. So let's look at the first one. This is about cell phone plans. And way back in the day, this is exactly what happened. You could do an unlimited data plan, and that's typically what people kind of do now. But there was another type of plan. So first is an unlimited data plan where customers pay a set monthly fee and they get unlimited data, right? The next kind of plan is a per gigabyte price where the customers pay a set monthly fee and then plus a specified amount of gigabytes, and then it says the gigabytes are not prorated. That means it doesn't matter if the customer uses 0.001 or 1, they're still paying for the entire 1. And so it says the cost of the phone and other fees are the same for each plan. So this is kind of how the plans are outlined. You have an unlimited plan where you pay $80 per month, doesn't matter how much you use. And then the price per gigabyte. And so they say this is $35 plus $10 per gigabyte. And the question is, which plan do you think is less expensive? And this is definitely a group discussion. I'd have you talk about it in your groups for probably like 5 minutes, and then you would have to report back what your groups think about. So take a minute, maybe pause the video, and if I said to you, which plan do you think is less expensive, tell me which one, and then justify it with your answer. Explain it. Okay, so pause the video a little bit, and then go for it. All right, so I'm hoping your answer was, well, it depends, right? So my mother is just about 80, and so she's not on her phone a heck of a lot. And so for her, and I don't know what her plan is, but the first plan would probably be the best for her. If she's just using her phone, her cell phone, just to talk to her children, and she's not doing a lot of internet searches, this is probably the best one for her, right? But like if you're my children who are on their phones all the time, they definitely wanted the unlimited plan, right? The 80 per month. So the answer to that would have been, it depends, right? It depends on how much you use your phone. So the next page kind of does a pricing outline, okay? So this is the price per gigabyte. So let's just say you don't turn your phone on at all, you didn't use any data whatsoever, you're going to be, so 0 gigabytes used, you're going to be paying that $35. Oh, do you like my Halloween Band-Aid? I got a massive paper cut, so pardon the Band-Aid. Anyway, so if you use anything, if you turn on the internet or use any sort of internet or data up until 1 gigabyte, you're going to be paying $10 extra on top of the 35. So that's why they have 35 plus 1 gigabyte times 10. So for 2 gigabytes, you have $35 and then $10 for each gigabytes. And that's up, so like you've used a full one, and then anywhere between the one and the second one, you're going to be paying $10 for each of those. Okay? So for 3 gigabytes, it would be the first gigabyte costs you $10, The second gigabyte costs you $10, and any usage above that, but below or equal to 3, you're paying another $10. So you're going to be paying 35 plus 3 of these $10. Okay, we'll do this one more time. So for 4 gigabytes, it's $10 for the first, $10 for the second, $10 for the third, and then $10 up to and including the fourth. So it's $35 plus 4 of these 10s. And we're not going to write all that out again. So the next one would be $35 plus 5 of these 10s. And then if you use 10 gigabytes, it would be $35 plus 10 of these 10s. And then now they're going to just give it to you in general. So you have the starting value, which is $35, and then they're calling it T time. So T is the number of gigabytes you're using times 10, where this is the number of gigabytes being used. And we can fill in these values. Here, let's fill in a couple. You ready? We can fill in a couple of these. So this is going to be 45, and this would be 55, and this would be 65, right? This is the $1.75, 85. This would be, let's see, 10 here. Pull out my calculator, right? We've got 35 plus 10 times 10. Oops, can't see what I'm doing. Did you guys see that's 135? There it is, 135. 135, and then this is in general. Okay? We're going to come back to this. All right, now for the unlimited, right? If we use no gigabytes, it costs us $80. If we use 1 gigabyte, it's costing us $80. If we use 2 gigabytes, it's costing us $80. If we use 10 gigabytes, costing us $80, right? So all the way down the line, there is no change, right? It's going to be $80 no matter what. All right, so what I want to do is I want to practice graphing these, okay? So on the horizontal, this is going to be the input. It's always going to be this first column, the number of gigabytes used. All right, so this is going to be the number of gigabytes used, and then on the vertical is going to be the price paid in dollars. So in all those P&Ls where we had to practice graphing, this is the reason why. All right, so it looks like it goes anywhere from 0 to 10, right? Kind of basic, 0 to 10 gigabytes. This is the data values that we've collected. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I guess we could just set these up as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And for 10, we need to go up to at least $135 if we were on the per gigabyte plan. Y'all see that? So we've got to go up at least to 135. I don't know, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 15, 20, 25. That's not going to give it quite. How many we go by tens, okay? So $10, $20, $30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. Okay, that should get all of our points fitted on the same screen. All right. Find a different colored pen. All right, here we go. So in pink, I'm going to do the first set of ordered pairs. So this is where I'd have you turn off the video and just plot a couple of these points. I'm going to get us started, and then I'd like you to stop and finish, okay? So for the first plan in pink, this is the per gigabyte. If we don't turn on the phone at all and use up any data, we're paying $35. So $0.35. So pause the video and see if you can plot a couple of those points. Okay? Take a pause, and then I'm going to plot them, and we'll see if we get the same thing. Okay? So go ahead and plot. Okay. Let's see. So for 1, did you get 45? And 2, we're up at 55. 3, 65. Okay. 4, 75. And then 5, 85. And then we jumped up. For 10, we jumped up to 135. So I'm hoping that you'll see that this looks like a line, right? So I have a straight edge, I have a piece of cardboard. I'm just going to pop this down and connect these dots. So look at that. Our first line. This is definitely a linear relationship, okay? The next one, the next plan, I'm going to do in this purple color. It looks like if we don't turn on the phone at all, we're going to pay $80. If we use 1 gigabyte, we're paying $80. 2 gigabytes, $80. 3 gigabytes, $80. 4 gigabytes, $80, right? So it doesn't matter how many gigabytes we use, we're going to be paying $80. Okay, so now we can look at this, and maybe this can help us decide a little bit about which plan we should use. So in pink, it's cheaper for anything up into 4 gigabytes. And then as soon, do you see that? All the prices are below that nice horizontal line. And then as soon as we hit 5 gigabytes, our pink now, the pink is above. Do you see that? So it looks like if we're going to use 4 gigabytes or under, we should go with the first plan. Anything above 4 gigabytes, we're going to be going for the blue plan. Second plan, the plan that's a constant rate. How are we doing? We doing okay? So that's just kind of getting some practice plotting some points. And then here they just wanted you to fill in the monthly cost, which we kind of already did, but this is a good practice anyway. So for 0, it was $35. For 1, $45. 2, $55. So as I'm doing this, I want to talk about the starting value and the change. Okay? So do you see that the change as we go up every month or every gigabyte, the increase is changing by $10. So there's a change going on, right? It's increasing by $10, right? This change is what's called the slope of a line, all right? Now this one, this plan was a constant, right? So there is no change, or the change is 0. So the slope, we're going to talk about slope, of this line would be 0. Okay, so I'm going to label this. I'm going to call it, remember the pink plan. The change is $10. Change is $10. That, when we talk about change, another word for change is what's called slope. For this one, the change, you're being very loud, Joey. For this one, my son just came in and he's like an elephant walking in. This one, the change is $0. There is no change. And that is what is called a slope of 0. So when we look at these two plans, I want you to notice something. This pink line is increasing. Do you see that? So if you have a positive change, or a change that was increasing by $10 each time, the line is what is called rising because it has a positive change. This line is perfectly flat. I'm going to call it a flat line. It's horizontal, but this line is neither rising nor falling because the change was 0. Right? So these are two big pieces of information that we need to get down. All right, so before we do the next problem, the next problem situation, I want to look ahead, right? If you made a copy of this, I'm looking ahead at page 466. These are the definitions that we need to get down for the final, okay? A change. Well, that's what we just did. So a constant rate of change is what defines a linear relationship. So it says a constant change can be seen both with a table and the graph of a line. So if I said, you guys, let me find my chart again, I just lost it. If I said, what's happening? What's the change each time? You would say plus 10. Positive 10. That's the change. And if I said, what's happening here? You would say, there is no change. The change is 0. So when they talk about a constant rate of change, that's what they're talking about. A slope is a fancy word for this change. Okay? So a slope, and we'll talk about this quite a bit when we do some of my worksheets. The slope says, to understand the slope, is the relationship to the graph as a vertical movement of the line over the horizontal movement. Let me show you. It's just the change. So look, the vertical movement is 10 over 1 horizontal. The vertical movement is up 10 over 1 horizontal change. The vertical movement is up 10 over 1 horizontal change. So the change and the slope, I'm telling you now, and we're going to do some more with it, are the same. All right? The other thing we need to know are what are called the intercepts. All right? We need to get down what these intercepts are. So this graph has two intercepts, two vertical intercepts, right? Or y-intercepts. So this is a vertical intercept. Okay. And this is a vertical intercept. You're going to hear me call these vertical intercepts the starting values, because aren't those the starting values of the plans? If no data had been used, no matter what, those were the starting payments. $80, no matter how much data we used. $35, no matter how much data we used. All right, so the vertical intercepts are those points that are on the vertical. They have a y value but no x value. So this vertical intercept would have been 0, 35. And this one would have been 0, because you didn't go to the right at all, 80. But you went up 80. So there's no input. The input 0, and the output is whatever on your vertical axes. And these don't have a horizontal intercept, so we're not going to worry about those. And we're going to talk about this linear model in a little bit. Okay? All right. So let's look at this one, the datas. I mean, we've answered these already, but we'll just fill in. I'm on page 467. So what are the rates of change of the two models? Okay. So for the first model, the rate of change is $10 per 1 gigabyte, and the other rate of change is $80. I'm sorry, is $0 per 1 gigabyte, because it doesn't change at all. The rate of change was 0. The vertical intercepts we've already answered. The first one was 0.35, and it means that you're going to be paying $35 if no gigabytes were used. And the second one was 0.80, and that means we're going to be paying $80 if no gigabytes are used. All right, and there aren't any. There are no horizontal intercepts for these. Okay? All right, so let's now go to the second. Let's go to the second problem situation. It's called the daily latte. All right, you guys see it's on page 4. If you photocopied it, it's on page 463. It's right after the chart problem. Let's see if I can get some better light in here. All right. There, that's a little bit better. Okay. So it says a local coffee shop offers a coffee card that you can preload with any amount of money and use it like a debit card each day to purchase the coffee. So at the beginning of the month, you load it with $50. And your favorite soy latte costs $2.63. So it says pretend you purchase a latte every weekday, so 5 days a week. And we need to know if we're going to have enough money that it will last us until the end of the month. Okay? So I'm on the next page. Here's a little chart. So if I don't pay any, if I don't buy a latte yet, I have $50 on my card. So on Monday, when I buy my first latte, I subtract $2.63. Okay? On Tuesday, I'm going to purchase 2 lattes. So I'm going to subtract 2 of these. Or maybe you would want to write it as 50 minus 2 of these 263s. Okay, on Wednesday, I purchased 3 lattes. Or, if you'd rather write it like this, right? How about I just keep writing it like this? So Monday, Tuesday, Wednesday, Thursday. On Thursday, we'll have purchased 4 lattes. Okay, and then if we had 5, by Friday, this would have been 5. After 2 weeks, we'll have purchased 10 lattes. Let's start figuring out what some of these are, okay? You ready? So I'm going to write it in pink. I don't know if you can see, my calculator's kind of bright outside right now. So we have 50 minus $2.63. So that's my first latte. I'm going to have $47.37 left on the card. Okay? All right. The next day, I'm going to purchase another latte. So I'm just going to subtract $2.63. So I'll have $44.74. Okay. On the third day, $42.11. Okay. On the fourth day, here, let's plop it in like this. Minus 4 times 263. We'll have $39.48. After 10 lattes, we'll have $23.70. Oh, let's see. 15 lattes. Okay, so probably imagining there's 4 weeks, 5 days. So this is the end of the 3rd week, right? Purchased 15 lattes, so we have $10.55 left on the card. This is the amount that's left on the card. So you see it's going down, right? Which makes sense. For 20 lattes, that'll be 50 minus 20 times 263. So this would be like a full month's worth. What happened? Negative $2.60. So we don't have enough, right? We've run out of money. You see that? Not enough cash on it. All right. So let's draw a graph of this as well, so we can kind of get a visual of what this is going to look like. Okay. So here's our old graph. So on page 465, I gave you another sheet of graph paper. It says, graph the data from the table. Be sure to include the scale and labels on the axis. It says, let the horizontal axis be the number of lattes purchased. Okay, so this is the number of lattes purchased. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I don't think we can get to 20, but remember we ran out of money if we had 20 purchases on our $50 card. All right. And we're going to start off with $50. Let's see. 2, 4, 6, 8. 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46. All right, so I'm going to start at the tippy top of the card. And this is I'm going to go up by 2s. I think I can make it up to 50. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. Okay, so the vertical is going to be the amount of money on the card. So it should be going down, right? The more that we purchase, the amount of money on the card should be going down. All right. So if we haven't purchased any lattes, we should have $50 on our card. So that'll be a dot right there. All right. If we've purchased one latte, we're down to 47. Okay. So halfway between 46 is 47, and it's just a smidge above 47. We're just going to eyeball it. After 2 lattes, we're down to $44.74. So it's somewhere, it's close to 45, but a little bit under, so we'll just pop it right there. Okay, and again, if we were in our groups, I'd kind of have you guys take a pause, and I'd have you plot these on your own, report back what was happening with your graph. Let's go ahead, we'll just go slow. So for 3 lattes, we're just a smidge above 42. You can already see this nice line forming, can't you? For 4 lattes, we're just about at 40, but not quite. Okay, so I'm going to just kind of put right there. And then we jump down to 10 lattes. So 10 lattes, we're at, above, just about to 24, but not quite. Right, see how I'm doing these? And then 20 lattes, let's do 15. We're at $10.55. If we're at 15 lattes, and I'm gonna see if I can draw a nice connector with these, okay? Take my little piece of, let's see if I have a ruler. I don't think my cardboard's long enough, so I'm gonna do this. I'm just gonna, all I did is I folded a piece of paper in half. Okay. And yeah, they're all kind of nicely lined up, aren't they? They look pretty good. Let's see. Okay, so trying to connect the dots as best as I can. Looks something right maybe around there. Okay. All right, takes a while to line those up. There we go. Wish I had a ruler, but I don't have a ruler. Okay, something like that. Yeah, that crossed through most of my points. All right, so this looks very different than the other two graphs. Don't you agree? The other two graphs that we graphed for the phone plans, one was rising, one was completely horizontal, right? Didn't rise or fall. And this one is falling. Okay, so we've graphed 3 different types of lines. Now, let's see if we can understand the linear model that would go with this. It says build a linear model. All right, so I'm going to start giving you hints about this. To build a line, we need to understand how they want us to label the input and the output. So I'm going to let the input be the number of lattes. I'm going to call this N, right? And then the output, they said, is amount on the card, so they said let's call that A. All right, so this is going to be A equals something. Now, for a line, you always have a starting value. So in this case, the starting value is $50 because that's what our card started off at. Now you're either going to add to this or you're going to take away something. Now in this problem, we're going to take away something because every time we purchased a latte, we were taking away $2.63. And these are the two pieces that you need in order to make a line, an equation for a line. You need a starting value, and then to that you're going to add or subtract a value times a number. So in this case we were subtracting the number of lattes times the 263. This 263 is the change because every time we buy a latte, the amount on the card goes down or changes by $2.63. So a line has two pieces. It has a starting value and a change. And that's all you need to know to make a line. Starting value and a change. If the change is negative, your line is going to be falling. If your change is positive, like when we were adding money to the plan because we used more gigabytes, then the line is going to be rising. And if your change is 0, you have this nice horizontal line. Okay? So those are the pieces that we need. All right? So let's look at the vertical and the horizontal. All right? So the vertical in this problem would be 0, 50. And they're going to ask you on the final, like, what does that mean? So that means when no lattes were purchased, we have $50 on the card, right? There is $50 on the card when no lattes were purchased. Now this does have a horizontal intercept, all right? So it looks like we ran out of money between 19 and 20, but you can't buy like 19.1 lattes. So this horizontal intercept is when we ran out of money. Now I don't know what the value is. We could eyeball it and say like 19.1 or 2 comma 0. But this is the point. This is where there is no money left on the card. So we could purchase 19 lattes, but after that we did not have enough to purchase 20. Okay? All right, so I think it does have a horizontal intercept, and that's where we ran out of money. So we answered that question and this question. How can you tell from a graph if a linear model has a negative slope, a positive slope, or a slope of 0? All right, so let's go ahead and answer each of these. If you're looking at a graph of a line, there are 3 types that we're going to look at, and I'm going to give you all 3 right now, and then that's what we're going to start with on our video on Wednesday, which I'll probably post today anyway. All right? So there are 3 types of lines that we're going to look at, and you can tell if it has a, remember the slope is change, if it has a positive change, a negative change, or a change of 0. If you look at the line, and as you go from left to right, the line is rising, this has what is called a positive change, or a positive slope, all right? So this would have a positive slope, because the line is rising. Remember, the slope and the change are the same thing. If you look at a line and it falls as you go from left to right, it's what's called a negative slope or a negative change, because the line is falling. And if you go from left to right and you don't rise or fall, it's just this nice horizontal line, this has a slope of 0. It's not rising nor falling. So the change is 0, or the slope is 0. All right, so that's section 4.1. I would recommend watching this video again and really trying to understand the highlights. And then we're going to start the next video by looking at these definitions, okay? And then trying to understand these problems when it comes to some applications. And if you can understand this, and you can understand the applications that I gave you, you'll be fine on the final, okay? You'll be great on the final exam. So it's really important that you ask me questions on this, okay? So I would watch this again if you have the time, and then watch the next video a couple times with all the applications on it, and then you'll be all set for the final, okay? Make sure you let me know on Wednesday if you have any questions. All right, so hopefully I'll see you soon.